Hi there. So I'm looking at a question on how to differentiate a complex looking natural law function, but you realize it's not really um, that difficult once you clear up the algebra. Another thing also worth knowing is that you need to have a few um, prior knowledge when you do this. You should also know how to use the chain rule. You should also definitely know um, certain basics about logarithms and also um, how we this is the chain rule. Okay, definitely come in handy. You should also know how a few things with regard to logarithms, and also how to generally differentiate natural log functions. Okay. Right. So before I start this video, again, I make that small appeal this time around that if you wish to make any contribution, just contact me at the email address that I've indicated here. Okay. See how you can reach out to help make this project a success, and also maybe one can offer extra tutorials and materials to you. Of course, um, you can definitely contact me there, and I will definitely get back to you. You can drop your details, whether it's your phone number or so on, and we'll see. Right, let's get to this question here. Of course, this is question 3 on my series on practice questions as far as differentiation is concerned. There's quite a number of things that you need to do here, but let me just first also write down just a few general concepts when it comes to how to differentiate natural log function. Suppose I have got the natural log of a function, then dy dx of this function, the derivative of this function, is simply the derivative of the function that is f prime of x over f of x, whatever that inside is. So it's the inside function comes under, and then on top is derivative of that inside function. I hope you get that. So let's look at a few simple examples. So if you have something like y natural log of let's say 2x, again as I said, dy dx is just going to be that 2x comes under, and whatever you have on top is the derivative of that 2x. The derivative of 2x is 2. So at the end of the day, you're just going to have 1 of x. I hope that makes definitely sense to you as far as that is concerned. Okay, and so you can play around with quite a number of stuff. Even if I have to bring in another one, so let's say I have y equals to the natural log of ax plus b, the derivative of this d by dx of the natural log of ax plus b is simply that ax plus b, and on top the derivative of ax plus b, which happens to be a. Okay, so we will be playing around with that, and this is a very important concept that you need to understand, especially when you even look at things like integration. We are definitely going to make use of this, but that is very important. So I'm going to use that as I'm explaining and going on. But before I start differentiating, the function is quite a bit messy. It's quite, you can't be using the product rule or quotient rule and stuff like that. So what you can do is you can use some of the laws that you know with regard to logarithms. So the first thing is, it's very important to know how you can write them separately, and I'll continue as I'm working through it, and I hope you follow. But the law that I want you to take note of here is I want you to take note of things like this. If you have log of a b, it's the same as log a plus log b. Similarly, if you have log of some number over another number, it's the same as log of a minus log of b. And of course, I'm going to look at things like the power rules, bringing those powers back to the front. So that's what I'm going to do. So I'm going to separate this. So I'm still going to do algebra. So this is the natural log of that denominator, which is x squared, and this is the sine of 3x, and it's raised to the power of a third, because this is the cube root is power of a third, minus the natural log of, again, 2x squared plus 5, again, it's raised to the power of a half. Now, there's also a few other things that you need to know, especially when it comes to how to derive or find the derivative of some basic trig functions, because we're going to deal with that. So, for example, d by dx of, let's say, the sine function, sine of x, is nothing but cosine of x. So there's also something that will come in handy as we are looking at this question here. Okay. Then perhaps I should continue further, because I'm not yet starting differentiating. I'm just trying to make my function looks a little bit neater by using, obviously, my logarithms laws of logs, or the properties of logs. Here you have the natural log of some function multiplied by another function. So it is that condition where I say log of AB. So I can separate them by adding the logs of the same bases. So this is what we're going to do. We're going to say, okay, here I have the natural log of x squared plus the natural log of, you have got, let's just make sure that we don't lose power over here, because I'm seeing computer is acting up. No, it's just a little bit off. There we go. All right, where was I? So we're gonna have the net plus natural log of that sine 3x, of course, raised to the power of a third, okay, minus, I'm going to leave this one as it is, 2x squared for now. I'm going to leave it like that. Now the next thing that we need to do is just bring those powers in front. So I'm going to have 2 natural log of x plus a third natural log of sine 3x minus a half. Then I have the natural log of 2x squared plus 5. Slightly better. Okay. So we're going to have the sum of the derivatives, means we can do the derivatives of the sums, and the differences, that means we can do, if I have to bring in another color, so I'll be saying, there's also another constant multiple thing that you need to understand. Whenever you have something like this, you just take out the constant and then you say d by dx of the natural log of x, okay? Plus a third, take out the constant multiple, then you have d by dx of the natural log of sine of 3x minus a half, then I have d by dx of the natural log of 2x squared plus 5. So basically I'm going to differentiate. Now here's the thing. How do you differentiate? This is going to be 2 multiplied by 1 over x, okay, plus a third multiplied by. Now here you must be a bit careful. So the natural, when you differentiate the natural log of something, I said it is, I'm going to start drawing myself a long line. So I'm using this fact, perhaps I've removed it. So what I'm using here, I'm using the natural log of some function of x is going to be, if I do d by dx of it, it's going to be that f of x, that function of x. In this case, I'm going to take sine of 3x. That's what I'm going to do. And on top, I'm just going to find the derivative of that. Now, here is what you need to be a bit careful. Don't make mistakes. The derivative of sine x is cos 3x. But then it's just not sine x, there's a 3 there, so you should also multiply by 3 because you are doing the chain rule within there. Okay, so I will do it a little bit on the side so that you can understand as I'm continuing. So make sure you record. So what I'm saying is I'm doing the derivative of sine 3x. So I'm doing d by dx of this. So it is the cos of 3x, that is the derivative of sine of that, multiplied by the derivative of the inside of 3x, which is 3. That is what I have over there. Okay, hope you understand that part. Right. So I'm gonna remove that for, let's just let it marinate and you can have a look at it. Minus a half. Now when I come here again, the derivative of this, again, remember what I said, that is multiplied by that 2x squared plus 5. On top, I'm going to have what? You figured. I'm going to have the derivative of that, which is just 4x. So it's getting a little bit better. So let's just clean up what we have. So this is 2 over x plus. Now here, something that we can do, we can obviously cancel out this 3 and that 3, not this one, please. Okay, so what we're left with eventually is cos of 3x over sine of 3x. Okay, then another thing that we can see, again, we can see that, wait a minute, this 2 can go in there, and we have a 2. So I'm left then with 2 all over 2x squared plus 5. Now we're nearly completely done with that derivative. It's just, something that looks a little bit familiar. And what is familiar is this over here. Okay, this is, remember, sine over cos is tangent, but cos over sine is the cotangent. Okay, it's 1 over 10. So this final answer would therefore be, the calculus is done, just have to make sure. So dy dx is equal to 2 over x plus cot of 3x minus 2 all over 2x squared plus 5. There you go. That is the derivative of that rather long, big natural log function. So the objective here was just to show you how you can use your algebra, your previous knowledge that you have, make the thing a little bit easier. Don't try to go ahead and say, I must use the quotient rule and product rule and stuff like that. And until it's such a time where you have that, okay, then you can only start differentiating. So basically, this is still y and that is still y. And only from there, now I'll definitely apply that. Okay, then there is one more practice question that I have, and it has to do with differentiating a trig function. Stand by for that one.